Let's talk about odds. Sometimes odds are used instead of probabilities to describe how likely an event is. The general idea is that in probability, we contrast the event against the whole. In odds, we contrast the event against the complement. That ends up giving us a couple of formulas. Odds for E. Here we're going to write this with an equal signs. Odds against. If you're talking about the odds for an event, we put the event on top and the complement second or below. When we're talking about the odds against, we put the complement first or above, and we put the event second. That's the way you want to think of this. And so we usually write odds as ratios of whole numbers, but remember, a ratio of whole numbers can be written as a fraction, which writes it in the form up above there. Let's do an example. Let's suppose that we roll a pair of dice. We want to figure out the odds for rolling a sum of 3 and the odds against rolling a sum of 3. Okay, so our sample space is going to be the set of 36 ordered pairs that we've seen so many times before. And let's let E be the event that a 3 is rolled. Okay, so then if we look at our event then, what's it going to be equal to? The ordered pair 1, 2, and the ordered pair 2, 1. So there are 36 altogether. 2 simple outcomes give a 3. So how many do not? 34 do not result in a 3. So our odds for getting a 3 are going to be 2 to 34, or that'll be 1 to 17. So we'll usually write that as a ratio like this, 1 to 17. That's odds for a sum of 3. Remember, the event, if it's odds for, the event comes first, the complement comes second. Let's look at the odds against. Okay, so this time we put the complement on top. So we put the 34 outcomes that do not give us a 3 on top. The 2 that give us a 3 are below. And so this is 17 to 1. Now I know 17 over 1 simplifies to 17, but when it's an odds, we want to write it as a ratio. So we'll write that as 17 to 1. Or it would also be okay to write like this. Okay, but you want to write it as a simplified fraction, but not an integer, or else as a ratio of whole numbers. Now, I didn't really use the formula there because I think using the formula kind of helps you to lose sight of your intuition on this and the fact that we are contrasting the event against the complement. But if you wanted to use the formula, here's what would happen. Okay, the probability, whoops, that's not what I meant to write. The odds for E was equal to the probability of the event divided by the probability of the complement. And so what's the probability of the event? 2 over 36. What's the probability of the complement? 34 over 36. Yes, you could simplify those. But if they have the same denominator, it's easier for you to see what's going on. So 2 over 36 times 36 over 34, which gives you 2 over 34, or 1 over 17, which is the same. I apologize for the dog barking in the background. I think he needs to go outside. Okay, so 1 to 17. So you can use the formula, but just think of contrasting the event against the complement. Let's do another one. What are the odds against rolling an ace when drawing a single card from a standard deck? So my A is my set of aces, and so then my A complement would be the non-aces. Okay, how many aces do we have? 4. So how many non-aces do we have? We'll take 52 total cards, subtract the 4, and so that gives me 48 non-aces, right? Okay, so if I want to figure out the odds against, okay, I put the complement on top, so that would be 48. Put the event below. The complement comes first if you're talking about odds against. My event comes below. So 48 to 4, which would be 12 to 1, so 12 to 1. I'm going to write it as a ratio. Okay. Just make sure you decide correctly whether it's odds against or odds for. If the number that comes first is bigger, that means that one's more likely. So when we're talking about the odds against getting an ace, we should have more non-aces than we do aces, and so our first number should be larger. And it is. You just want to kind of double check that to make sure you haven't got something switched around. Let's suppose that a child has a 0.08 probability of developing a certain disease. Okay, and so now we want to find the odds against the child developing the disease. So the probability of the disease is 0.08. So what's the probability of the complement? We take 1 minus the probability of the disease, so 1 minus 0.08, which gives me 0.92. There we go. Okay, so now let's find the odds. So we're going to put, since it's odds against, once again we're going to put the complement on top. Okay, now these are both written as a decimal, so let's just divide them, multiply both of them by 100. You'll probably do this in your head and not write it, but that's okay. I'm going to write it. So we end up with 92 to 8, which we can simplify to 46 to 4, and then 23 to 2. You want to simplify it as far as you can. Now, what if we start with odds and we want to go to probability? If the odds for an event are m over n, or m to n, then the probability will be m over m. This should be a plus. That's very important. Sorry, this program doesn't seem to do really well at some of the plus and equal signs. Here, remember what we want to do with probability is we want to contrast the event against the total or the whole. And so that's why we need to add the event and the complement, those chances or those simple outcomes together to get the total. That'll be our denominator. For odds, we're contrasting the event against the complement. Okay, so the odds against the horse winning are 7 to 1. So let's see. Let E be the event that the horse wins. And so the odds against E are 7 to 1. Okay, so here this means that that's our complement, so that means the horse loses. This one is our event, so that means that the horse wins. Okay, so now what is my total? 7 plus 1, so 8. Really, we're going to contrast in odds the chances of winning against the chances of losing, or in the case of odds against, losing against winning. Event probability, we want to contrast the event against the total. And so now we want to figure out which side is the winning. Odds against means the complement comes first, so winning comes second, and so my probability that he wins will then be 1 over 8. And you can look at the formula above and see that that does match up. But I think of it as a concept and don't really memorize a formula. Let's do another one. Let's suppose an insurance company has used past flood data to determine that the odds against a particular house flooding are 150 to 1. You'll notice I've used odds against a lot here. And that's because that's what you'll usually hear. If you hear odds being used on the news, you almost always will hear odds against rather than odds for. It's not universal, but odds against seems to be more commonly used. The odds against a particular house flooding are 150 to 1. And so we want to figure out the probability that the house floods. So which one of these, we need to figure out which one of these represents the chance that it floods. Since we have odds against the house flooding, that means the event is coming second. So the second number will be that it floods, and the first number will represent the chances that it doesn't flood. Okay, so flood, there we go. So now we want to figure out the probability that the house floods. So what are we going to do? We're going to figure out what are the chances that it floods, or the simple outcomes when it floods. 1, right? What's the total? Remember, in probability, you contrast the event against the total. So we end up with 1 over 151. Whoops, 1 over 151. Let's approximate this with a decimal. You should get about 0.0066. Okay, well, I hope this helps you understand a little bit about the difference between odds and probability and how to go back and forth. I hope this helps. We'll see you next time. Good luck.